Welcome, everyone. This is the KubeCon North America update meeting of the Working Group Device Management. And yes, this is the place and talk where we are going to cover dynamic resource allocation, a small thing that you might have heard about. And yeah, we have done more on it. We do these update meetings pretty much every KubeCon, or at least the KubeCons that we go to. So the last one was at KubeCon Europe. And we are going to cover new content that went into Kubernetes 1.34 and the one that we just almost finished with 1.35. My name is Patrick Ohly. I work for Intel on Cloud Native. I've been doing dynamic resource allocation for a while. With me on stage is Kevin Klues from NVIDIA. And in the front row, we have John Bellameric kicking it back and enjoying that he's not talking in here, but he will be available for questions. If you get the slides later on, all of these are links to our working group. We'll also have it on the slide later on again. So, what is the working group and why do we have it in the first place? So as I mentioned, we have done DRA, dynamic resource allocation, for a while, even before the working group was formed, but it became fairly popular at some point and we decided that we really need to have a place to discuss it. And a working group in Kubernetes is cutting across multiple SIGs. In this case, we have pretty much all of the major ones, in fact, included. It's an architectural change for Kubernetes. It changes what Kubernetes is good for. It affects the node part where we actually have devices. That's where it came from originally, but it became very scheduling heavy because we need to make very difficult decisions in the scheduling part. That also affects then auto-scaling. And we've branched out in terms of what kind of devices we are supporting in reality today with drivers. So SIG networking is involved because they want to make sure that the devices that are network hardware also work well. So I've mentioned hardware. It's started out as focusing on GPUs, but it's certainly not limited to that. Network devices are covered by existing drivers, and we have an overall design that is supposed to be flexible enough to cover everything that we want to do with special hardware in Kubernetes going forward. So DRA, as I mentioned, is a large part of what we've been focusing on, but we kept discussing other things in the scheduling space just this week, and I think we kind of have a tentative agreement that this is the working group where we are also going to cover advanced scheduling topics in general, like gang scheduling, but stay tuned. I think we will branch out and we will just continue discussing all the problems that you people have and try to come up with a solution. So what actually is dynamic resource allocation? You can think of it as a replacement for device plugins. That's where we started, and we wanted to have something that is more flexible. First, in the first part, how do we actually describe hardware? With device plugins, you just have a count, a list of devices at the node level, and then it gets exposed in the node status as a list of things, but it's really just a string and a number. That's not very expressive. With resource slices, we have a way to list devices. Each device can have attributes. An example might be an NVIDIA GPU with a certain amount of memory as an attribute, a certain number of compute cores. That's how the scheduler is informed about what's available. The user then requests devices, again, using a new top-level type, the resource claim. And that resource claim can have filters that are based on these attributes of the device. So you can have a very specific requirement. If you want just a special CPU, a GPU of a certain vendor, you can ask for it. Or you can be more flexible if you are okay with some other kind of GPU also. You can express that. You can also provide configuration parameters, something that just didn't have a place in the traditional extended resource API. And that configuration could basically tell the driver on the node how to configure the hardware when it makes the hardware available for specific workloads. That could change between type slicing, for example. Things like that can be configured. It's opaque at that point to Kubernetes. but it gets passed through. So we have a reliable way to specify that, handle it, pass it down. The third part in core Kubernetes is the scheduler. So that's where we do the mix and match. What's available, what does the user want, what is in use at the moment, and then we allocate the resource claims. And when we have an allocated resource claim, we record for which pod it is, we schedule the pod, and then the fourth step happens. The kubelet sees a scheduled pod, it gets the resource claim, it knows which driver it needs to notify, and the driver on the node makes that hardware then available. The resource claim is also very flexible in terms of who's getting access to it. So you can share a single resource claim between multiple pods. It gets prepared once, and then different pods get access to it. You can say inside your pod which device gets used in which container. So you can basically mix and match arbitrarily as needed by your workload. And perhaps the big announcement, we actually reached GA in 1.34. Thanks. This is my chance to say it. I think it has been mentioned in the keynote this morning. It's not news, but it is an important milestone because people have been waiting for it. It is GA in core Kubernetes, the basic functionality, and people have been waiting for that because it means that they can now start using it in DRA drivers. So what I described so far is the core part, what we support in Kubernetes, but Kubernetes itself doesn't manage any hardware. That is what we need drivers for, like we did with device plugins before. We do have a bunch of those publicly available from NVIDIA, from Intel, from Google, doing different things, in fact. Some of them are for network devices, like DRA net. Others are for GPUs, the Intel ones, NVIDIA, Furiosa AI. And we want yours to be listed also. So we do not do that in the core Kubernetes documentation because we have a policy in Kubernetes that we are vendor neutral. But we do have in our working group repo a README file where it is okay if you just go and submit a pull request and add your driver just to inform others, because it is useful to have one place to see what's going on, and it helps us if we compile such a list that we actually know where your stuff is. So you're welcome to add that. The barcode will take you to the place. It's a bit hidden, but if you know where it is, you'll find it. So yeah, let's talk about the other big thing. Besides GA in 1.34, we started branching out. So the core idea always has been that we have core functionality that we need to get to GA as quickly as possible because people were waiting for it very urgently. And we didn't want to delay that graduation to add more things. Instead, what we are doing is we have branched out, we have additional caps, and I'll show you a very long list on the next slide. These are the main ones, perhaps, that we added in 1.34. The first one is something that eases the graduation or migration of a cluster, an entire cluster, from traditional device plugins, extended resources, to DRA. So it's a quality of life thing in some extent, but it also simplifies the request mechanism. What it does is that the traditional extended resource requests in a container get mapped to a DRA device class, perhaps by matching the name or by a field in a DRA device class. And the scheduler, when it sees a traditional resource request, will automatically figure out whether on a certain node that resource is provided by a device plugin or by a DRA driver running on that node. That's the first advantage. So workloads don't need to be modified to continue working in a world that moves on to DRA. And we'll support that in perpetuity. It's a simpler request mechanism than using resource claims directly. It's also more limited, of course, but it's your choice which of these two APIs you are using, and it's not dictated by the cluster. The other choice that an admin has to make is on a node, a certain kind of hardware can only be provided either by a device plugin or a DRA driver. We can't do both. that would be potential race or oversubscribing a device. So it is a choice, but you can gradually convert a cluster. Start with a few nodes where you try out DRA, and then you continue. The other thing, binding conditions, is a new way that gets a bit more dynamic back into dynamic resource allocation, because we have the ability to block pod binding until a controller does something with a pending allocation. It's used to attach devices to a node at runtime before scheduling the pod. If it goes wrong, the pod goes back and will be rescheduled. That's the difference compared to scheduling it onto the node and then failing on a node, then it's stuck. It's a different failure mode. And last but not least, consumable capacity is another extension of how complex or what a device is. We had another talk on that just today, earlier. It makes it possible to share the same device until its resources or until some capacity is exhausted. That's a new way of making device sharing a bit more dynamic than what we had before. Now that's a long list, but to give you just an idea. I'm not going to go into the details. All the caps that we are currently have pending, their state as they were at certain Kubernetes releases. In this release 135 that just almost wrapped up with code freeze last week, is where we improved some of these features that I just described. So they stayed at the same stage. We haven't graduated anything, but they are now feature complete. And we hope that with your feedback, we will be in a position to say, yes, it works. It does not need further changes, and we can graduate them in 136. That's the plan for several of them, including the extended resources, all of the free that I just mentioned. And some others have other concerns where we just wanted to have a bit more time, but I expect quite a few graduations in 136. So I've talked about features. Now I am coming to the part where I actually perhaps even like a bit more than just talking about features. It's about the persons that have made that possible. And we have had new contributors helping us with that whole effort. Some of them even contributing to Kubernetes for the first time. Let me just call them out. First is Pang, consumable capacity. She's been driving that for a while, doing a very diligent job defining a cap, implementing it for 2 releases, and now it's complete. Yu Liao has taken on the task of extended resources, got a little bit of help from Sai in the last cycle. Ohly has really stepped up, helped us with GA graduation, doing the scale testing. That was tremendous. It really helped us a lot, unblock the GA, and also helped out with the others, extended resources, KubeVirt, Q. And some people from Fujitsu, they are into the dynamically attaching devices. They implemented, Kobayashi, Daisuke implemented that in 134, and in 135, Tsubasa, Tabarabi continued driving that feature forward. And with that, I hand over to Kevin.
Thanks, Patrick. Yeah, so first thing I wanted to cover really quickly is just to call out a bunch of the different talks that we have at this KubeCon related to DRA. And I think past KubeCons, a lot of the talks we've given have been dominated by NVIDIA, Google, and Intel. But at this KubeCon, we actually have quite a few from other companies. Most notably SCEDMD, IBM Research, and a few others from talks that have been given between Sunday and today. And then we also have a bunch of upcoming talks that will be happening tomorrow and on Thursday with contributors from Red Hat, Microsoft, and FluidStack as well. So it's just great to see all of the community members that have started to step up and actually embrace DRA and start experimenting with it and trying out new features, and then obviously also giving talks here at KubeCon about it. So with that, I wanted to highlight a few of the new features and/or drivers that have been implemented since the last KubeCon, since we last gave an update on everything that's been going on. One of them is that a new driver, DRA driver for CPUs, has been pushed to as a Kubernetes SIGs repo that anyone can download, start playing around with, contribute to. And the idea is that you have the same way that you can use DRA to allocate GPUs, NICs, and whatnot, you can now use it to allocate exclusive access to CPUs as well. with the main goal of doing this being that you can actually align CPUs and GPUs on the same NUMA domain or PCIe root complex, also along with NICs, so that you can get a much more performant system by aligning all of these before you go and give your workload access to them. And in one of the demos that was given at a talk that was around this at the Maintainer Summit, one of the examples they gave is that you can ask for up to say like 20 CPUs, and you make sure that all 20 of those CPUs are aligned on the same L3 cache, and at the same time that they're aligned to the GPUs and NICs that you also give to your workload before you start it. So it's just a much richer and more feature-filled way for making sure that everything can be aligned all the way down to the CPU level. A second one is a DRA driver called DRA.net, which has now become generally available. I think there's a keynote on it tomorrow, either tomorrow or Thursday, I'm not sure. We're going to go into some of the details of what DRA.net is and how it works. But the basic idea is that it offers a DRA native way for pods to request access to high-performance networking resources, such as RDMA NICs. And just as what I talked about with CPUs, with DRA.net, there's a way for you to align your NIC allocations with your GPU allocations through the use of a new standardized attribute that we've published, that any DRA driver, if they publish devices with this attribute, you can use it to align devices across different vendors. And so using this standardized attribute across GPUs and NICs, we're able to see boosts of bus bandwidth by up to 60%. And the way you do this alignment is what you see on the YAML on the right. You can request a GPU, you can request a NIC, and then you say you want those two devices to be matched on this attribute of PCIe root, and then it guarantees that those two devices come from that same PCIe root complex. Another key thing that was added since the last KubeCon is we now have integration of DRA with KubeVirt. So you can start a KubeVirt VM, and you can make sure that DRA allocated resources are given to that KubeVirt VM. I don't think this has actually been merged yet. It has, sorry, has it been released as well? Or it has been released as well. Okay, sorry, take that back. It has been both merged and released, but it's alpha level support. So you have to enable an alpha feature gate in order for it to be used. Next one is queue integration. So, queue has its own mechanism for allowing you to set up quota on devices that are given to a pod that are launched with queue. And the queue integration that we have allows you to express these quotas against DRA allocated resources the same way you've been able to in the past with your extended resource allocations. And so, it's just yet another integration that we've done and seen in the community beyond just writing drivers and adding new features to Kubernetes core. We're seeing these integrations start to happen in external components, third-party components as well. And then last but not least, I talked about this a little bit at the last working group device management update, the support that we built for multi-node and VLink with NVIDIA GPUs. But since that time, we've now released an official version of our driver that supports this. And we wrote a blog post about this that was published on Monday, which is available at the URL at the bottom here. And I'm happy to answer any questions about what this looks like and how it works after the talk if anyone's interested. So with all of those integrations, those couldn't have happened if we didn't have people in the community actually working with us on all of these features that we're building. And so we just want to give a shout out to allow you guys to invite you guys to join us in this effort. We have weekly meetings every other Tuesday at 8:30, or I guess we have weekly meetings, one in a PST time zone at 8:30 a.m. and then on alternating weeks at 9 a.m. in the Central European time zone. We have a very active Slack channel. There's questions posted almost daily on there, and all of the core members that have been contributing to this are there and available to answer questions. We have a less active mailing list, but the mailing list is there for announcements, and we encourage you to join that in case there's something that we want to spread more, broadly that we want people to get access to. And then we've got a community page, which has our charter and some of the other things around what the device management working group is responsible for and what we're going to be working on going forward. Okay, and with that, We'll take any questions you have, and feel free to scan this QR code and give us feedback after the talk. Thank you. Not everyone all at once.
We answered all the questions.
We answered everything. If you have a question, come to the microphone here, please. Thanks.
The answer to this might be an automatic no, but I'm trying to solve network contention, and I'm considering using DRA, like a custom plugin, to basically hand out bandwidth to pods on a node. Is that a dumb idea to use DRA for that? I'm pretty sure it's mostly intended for splitting up the NICs or like more discrete resources, but yeah, that's something I'm interested in.
Good. Or John, do you want to? Yeah.
No, it is probably not a dumb idea at all. In fact, that's what the previous talk I did an hour or two ago was on a new feature. We have this consumable capacity feature, and the specific use case we talked about there was allocating guaranteed bandwidth on secondary NICs in your pods in a way that you don't oversubscribe them. So it sounds interesting. Like, I'd need to know a little more details, but feel free to reach out on our workgroup management workgroup device management Slack on the Kubernetes Slack, and we can see that we may even already have an in-the-works solution that helps you out.
Awesome, thank you.
And I feel obligated because Kevin talked about the CPU driver, and Praveen explicitly, who's developed it primarily, wanted me to emphasize it's alpha, the CPU driver. Don't start putting it into production yet.
Well, that was going to be my question, the CPU driver. Thanks for writing that, because I was about to start that project. On the subject of writing drivers, is there a framework for writing drivers beyond just the example driver?
So we do have the DRA example driver. If you Google for it, search for it, you will find it. It is meant to be the basis for third-party drivers. You can just copy the repo, rip out some small vendor-specific logic where we currently just pretend to have a certain number of GPUs, and you plug in your own logic. It interacts with Kubernetes through a helper package that we are publishing in the staging repo. It's under KAS Dynamic Resource Allocation kubelet plugin. But typically, DRA drivers are kubelet plugins. They can also have a control plane part, but typically they are node plugins. And that Go package has fairly extensive documentation. If you just read it from top to bottom, you will get a good understanding of what your implementation of a Go interface needs to do to work as a kubelet plugin, to publish resource slices. All the things that we are expecting from a DRA driver will be handled through that Go interface.
Gotcha, thanks.
And one other thing I'll add there, sorry, is there's a lightning talk on this from John. Is it tomorrow or is it Thursday? It's for tomorrow if you want to learn more about the example driver and how it's architected and what it all contains. Yep.
One thing that's perhaps worth adding, if you're using that Go helper package, your driver will automatically be compatible with all Kubernetes releases starting from 1.32. So it hides a little bit the details of gRPC API versioning, which resources, which API version is enabled in the cluster, and you automatically get fairly full support as long as you are sticking to the features that were supported by older Kubernetes. As soon as you start using things that we only recently introduced, you get a runtime error if you're trying to publish a resource slice, for example, that uses advanced features.
Cool, thanks.
Hey, hi, thank you for this wonderful session. I have two questions. If we wanted to build a cluster, is there any limitation? Can we use some of the nodes with GPUs and some with regular CPUs? Do you see any limitation if we do the topology?
Sorry, I missed the beginning of the question. Can you say it again?
Yeah, if we wanted to build a Kubernetes cluster, with some of the nodes with just CPUs, just regular nodes, and some of the nodes with the GPU with the high capability hardware. Is that okay?
Yeah, It's perfectly reasonable. When you put your request in for a GPU, the scheduler knows how to find the nodes that have the GPUs on them and make sure that the GPUs get allocated from those nodes, and then the workloads land on those nodes instead of the CPU-only nodes.
Okay. So just a follow-up question on this. Right, yesterday there is a session by Google, I think, on the intelligent scheduler. Is that part of this 1.34 intelligent scheduler, which basically schedule the pods on?
Sorry, again, I missed the beginning.
Intelligent scheduler is the
what scheduler?
I'm not sure. There was a talk.
Yeah. There was a talk yesterday that they spoke about intelligent scheduler. I don't know if the scheduler that's shown in the first slide is that the.
So the Kube scheduler is. I don't know what that talk was referring to specifically. Do you know who gave that talk?
No, I just heard.
Yeah, we can talk about it afterwards. I'm not sure. I'll have to look it up. Kube scheduler DRA is part of the standard upstream Kube scheduler. And so it's possible to build other schedulers. It's also possible to build extension. The scheduler has a lot of extension points. In fact, DRA is primarily an extension point and uses one of those, but or several. But I don't know what that talk is specifically referring to.
So does that mean that this scheduler that we get with this DRA, is that the new version of the scheduler?
This is the standard, yes, DRA is shipped as a standard API and standard scheduler plugin in 1.34 and later. And you saw that long list of caps. Caps are how we track feature enhancements in Kubernetes. We've got tons of work we're doing. So each of those individually needs to be enabled with feature gates until they're ready and made GA. But like the core functionality is there. And of course, you also need the drivers, right? So some of those drivers are already released, like DRAnet. Some of those drivers are soon to be released and in supported formats, but are there maybe in a preview format right now.
So perhaps my take on this is that all the features that we've listed will be supported in Kubernetes components, Kube Controller Manager, Kube Scheduler that ships with Kubernetes. All of that needs to be implemented. So if you bring up a cluster with just the upstream components, all of this works. As soon as you start replacing the Kube Scheduler with some other scheduler, then it might be a bit dodgy whether it supports the latest features. You would need to talk to the implementers of those schedulers to figure out whether they support resource claims, whether they support consumable capacity. Basically, look for a description of what you are deploying, whether it's as complete as the upstream scheduler. Not sure whether that helped, but.
Thank you so much. Thank you.
Thanks for the talk. This is very exciting, I think, for everybody who's been dealing with static allocation. I'm curious about auto-scaling. Does everything just work? Like VPA just works, node auto-scaling just works, or is that something that's still for the future?
So sort of, sort of just works. I mean, we don't have, so a couple of the things that have been added recently in Kubernetes are like in-place pod resize. In-place pod resize works with VPA to let a pod have its resources increased without, having to reschedule. But we can't change the resource claims. That's not yet part of in-place pod resize. So VPA works in that, yes, we can create a new pod that scales. I don't know that they've integrated resource claims in there particularly. Other auto-scaling, though, as far as like cluster auto-scaling, that does have DRA support that was built and should be available and should be working now. The trick with cluster auto-scaling is almost nobody uses upstream cluster auto-scaler. Every cloud vendor has their own. So I don't know about Carpenter. I'm from Google. I know that at Google, all of this will be supported with GK 135 as far as our drivers are concerned and things like node auto provisioning and all those pieces. We're targeting to be in our GK 135, which is coming up shortly after open source 135. So hopefully by the end of this year.
Okay.
Yeah, one other thing I'll add there is that you may, if you're reading documentation or hearing some of the people that have been involved in this project for a while, you might hear us talk about something called classic DRA. It's because about 3 years ago, or I guess 2 years ago at this point, we had to change the entire way that DRA was designed and operated, specifically because the original design didn't work well with cluster autoscaling. And so, the changes that we made were specifically with the ability for cluster autoscaling to work well with this design, even if it's not quite where it needs to be in the long term.
Okay.